Hello and welcome to STAIR Tailored. I'm Suzanne Forsyth and I'm with the University of Texas at Austin. And today we're going to talk about exploring the properties of quadrilaterals using the concrete, pictorial, abstract framework and AngLegs. First, we're going to look at this. This is the concrete, pictorial, abstract framework. And the idea is to give children, particularly children who are having math difficulties, multiple representations of the same concept to help them to more fully understand the concept and the relationships between pictures, real world representations and abstract representations that we often use in mathematics. These do not have to be done in any specific order, and to illustrate that fact, right now we are going to start with combining the abstract and pictorial parts of this framework. Now this right here would represent my word wall in my room, where I am helping children to understand how shapes are related to one another and kind of the hierarchy among them. Here I have polygons, and then different types of polygons underneath it. Triangles, they have 3 sides, quadrilaterals, pentagons, and just seeing that structure that if a shape is a triangle, then it is by definition also a polygon. If a shape is a quadrilateral, it is also by definition a polygon. If a shape is a pentagon, it is also by definition a polygon. With my words and definitions on this word wall, I'm also going to have multiple representations, and I'm going to have some examples and I'm going to have some non-examples to kind of help kids have to think about it. And right now we're just going to really focus on the quadrilaterals. And today we're going to focus on quadrilaterals. The definition for quadrilateral is any polygon with 4 sides and 4 angles. And I keep this idea of the angles in that definition because all of these different kinds of quadrilaterals, the definitions talk about either the sides or the relationship between the sides or the measures of the angles. And so both are important to the definition of shapes, so I keep that in there. Notice that with each definition I also put several shapes, pictorial examples. Some match the definition and some are non-examples. And I would have my students go through them and tell me which of these is a quadrilateral. Is this first shape a quadrilateral? No, that's not a quadrilateral. So we'd mark it out. Why is that not a quadrilateral? And they would have to tell me, well, definition says there's 4 sides. This only has 3. And we'd go through each one of these and they would tell me yes or no, and then why it doesn't match the definition. Then we would move down and say, okay, let's look at the trapezoid. The trapezoid is a quadrilateral. Notice I kept quadrilateral in that definition. I didn't say it has 4 sides. I am referring specifically that if it is a trapezoid, it is also a quadrilateral. Again, there's examples of quadrilaterals. There's one non-example. I would have them tell me this is not a quadrilateral, not a trapezoid, sorry. Why is it not a trapezoid? And I want them to explain that to me. Then I would move to parallelograms. Well, a parallelogram is a quadrilateral with 2 sets of parallel lines. Okay, so which ones of these are quadrilaterals? With kids with learning disabilities, you may have to go back and explain what are parallel lines and talk about that. What does it mean that they have 2 sets of parallel lines? Does this one have 2 sets of parallel lines? Does this one? And have them explain which ones belong to this group parallelogram and which ones do not, and mark out the ones that do not. And again, by definition, a parallelogram is also a quadrilateral. I left that in the definition. I don't want them to have to think about, well, is it a quadrilateral? A parallelogram by definition is also a quadrilateral. And I would move down. Rectangles. A rectangle is, I would keep that parallelogram, that word parallelogram, in the definition. A rectangle is a parallelogram by definition. It has 4 right angles. And I would maybe have to explain to them that right angles means they're 90 degrees, and what does a right angle look like? Again, examples and non-examples. Which one doesn't belong? And have them tell me, why doesn't it belong? Give me the reason using these definitions why that is not a rectangle. Same thing with rhombus. Notice again, I kept the word parallelogram in the definition. I don't want them to have to think, well, is it a parallelogram? A rhombus, by definition, is a parallelogram with 4 sides of equal measure. Again, it is a parallelogram. And if it is a parallelogram, it is also a quadrilateral. Lastly, a square. A square is a parallelogram. Again, leave it in the definition. We're not going to have to guess. It is a parallelogram. Be explicit. It has 4 right angles and 4 sides of equal measure. So it is a rectangle because it does have 4 right angles. It's a parallelogram with 4 right angles. And it is also a rhombus because it has 4 sides of equal measure. I often tell them it's a rectangular rhombus. Again, on these I would ask which one of these doesn't belong, which ones are not squares, and cross those out. Now I would keep this word wall up and I would change out these shapes as kind of a review each day. Have a different set of shapes and let them tell me, do they belong, do they not belong? If you put them on sticky notes, they can move them to where they do belong elsewhere. Anyway, those are working with the abstract definition of the shapes and also some pictorial representations and seeing how they connect to one another. Next, I want to show you some concrete examples of these shapes, or how to teach these shapes. And you'll see that there's lots of different manipulatives available to teach geometry to students. You can use pattern blocks. Pattern blocks are a little limited because they're just, there's one type of hexagon. There's one type of square. You can't really change the properties. You can use simple things like toothpicks and marshmallows, or popsicle sticks and clay, and that gives you a little bit more mobility. If you break the sticks, you can change the sizes, and that kind of gives you a little more flexibility with what types of shapes that you build. Also, the geoboard is a really good way to explore properties of shapes. And you can see this geoboard, this teacher has some different cards of different things that the students are making. But to really look at the properties of quadrilaterals, my favorite manipulative to use is AngLegs. So we're going to look at some AngLegs on the document camera. Okay, my favorite manipulative for teaching the properties of quadrilaterals are AngLegs. And the reason I like them so much is they come in different lengths, and all the green AngLegs are the same length, and all the blue AngLegs are the same length, and all the red AngLegs are the same length. So you can make polygons with all sorts of different lengths of sides and different angles. And this really gives you the ability to explore the properties. So we're going to work on building some different quadrilaterals. And I would have the students start with the definition because I want them to connect what they're making to a definition of these shapes, these polygons. So because I have planned ahead, I'm not going to want my student to make a square with the first quadrilateral they build. So I'm going to ask them to build a quadrilateral, but I'm going to give them AngLegs of different lengths so that they are making unusual shapes. And I will give you some examples. Let's say here's a quadrilateral. I might have them build 2 or 3 so that they're getting the idea that quadrilaterals have lots of different shapes and they're still quadrilaterals. I would ask them, how do you know this is a quadrilateral? Well, the definition says that it has 4 sides and 4 angles, and this has 4 sides. Then I'm going to have them change their shape just a little bit or manipulate their shape just a little bit. I want to know, I'm going to go through the different types of quadrilaterals. So next thing I might ask them to do is, can you make a trapezoid? Well, they have this quadrilateral. Can they make it into a trapezoid? And this is where I think AngLegs are so neat. You can manipulate those angles and change their orientation. So This one, we might be able to make it a trapezoid. I have exactly one set of parallel lines. I can't make it have two parallel lines. How do I know it's a trapezoid? I know it's a trapezoid because it has exactly one set of parallel lines. Can this one be a trapezoid? And you see how difficult this one would be? Well, there you go. There's a trapezoid right there. It has one set of parallel lines. So I would have the student manipulate these. Then I would ask them, okay, so you made a trapezoid. Can you make a parallelogram? What is a parallelogram? Okay, a parallelogram is a quadrilateral, and we know all of these shapes I made are quadrilaterals. It has to have exactly two sets of parallel lines. Okay, can I take any of these and make two sets of parallel lines? And because I have not allowed my student to have two sets of matching sticks, they can't make a parallelogram with their quadrilaterals. So then I might ask them, well, what can I do to this one to change it and make it a parallelogram? How can I make it have two sets of parallel lines? Okay, well, I've got these two blue lines. What if I change this one to purple? And there's a parallelogram. They may not be able to determine that for themselves, but as the teacher, you could say, well, why don't we try this? And then you have a parallelogram. It has exactly two sets of parallel lines. You might make several different parallelograms. Then I would ask, okay, you made a parallelogram. Can you make that parallelogram into a rectangle? Well, how would you do that? It is a parallelogram. We already have a parallelogram. It has 4 right angles. They can make it have 4 right angles. Another concept that this really helps with is determining area or perimeter, because often, well, almost all the time, you only have 2 lines that are labeled with length. And this really kind of helps them understand, well, these have to be equal in measure, or it can't be a parallelogram. Going from the rectangle, I would try maybe another definition. Well, can we make that rectangle into a rhombus? Well, how is a rhombus different than a rectangle? It is a parallelogram. It has 4 sides of equal measure. So then I would have to start giving the students AngLegs that are the same color so that they can make them have equal measure. But here's a rhombus. It has 4 sides of equal measure. I would ask them continuously, well, how do you know that it is a rhombus? Well, it's a parallelogram. Well, how do you know it's a parallelogram? Oh, well, it has two sets of lines that are parallel. If they have a rhombus that is shaped more like this, could you ask them, can you build a square? How do you make this rhombus into a square? And they would have to change the measure of the angles. And that would be how I would teach the relationships among these different shapes using AngLegs. And thank you for joining us today for today's STAIR tailored video, and we'll see you again.